special right triangles, watch, listen, and write down the notes as we go over them in the video. Make a right triangle by cutting the square in half. What do we know about a square? We know that the corners are 90 degrees. We know that each side is the same. So I'm just going to label each one 1 for now. And when we cut it in half, we're cutting it along the diagonal. So now we have a triangle with sides of 1, 1, and we know that it's a right triangle. And with the Pythagorean theorem, we know that a squared plus b squared equals c squared. So we can say 1 squared plus 1 squared equals c squared. 1 plus 1 is 2, and that's going to all equal c squared. And to undo a square, we do the square root. So this is saying square root of 2 equals c. Now if we extend that so that if we don't know the sides are 1, we're going to call them x, you'll see that the same thing is going to happen. Again, we have a right triangle with sides of x, so we can use the Pythagorean theorem. We have x squared plus x squared would equal c squared. And remember, c is across from that right angle. It's like an arrow pointing to your hypotenuse. 2x squares equals c squared. When you take the square root of both sides, 2 stays in the house. And because there are 2 x's, those are buddies, we can pull 1 out. And then the square and the square root cancel out, so we have c equals x square root of 2. This is extending it to a 45, 45, 90 special right triangle. The 45s come by taking this 90 and cutting it in half. So each would be 45. Same thing over here. 45 and 45 is 90. So what we have is our sides have a value of x, and our hypotenuse has a value of x square root of 2. So as we start doing these, we're going to get in the habit of making a table that goes with these. The 45, the side across from the 45 is a leg. The side across from the other 45 is a leg. So I'm going to label these legs, and this is the hypotenuse. So every single time, this special right triangle formula will work. The legs are valued at x, and the hypotenuse is x square root of 2. So now we are going to put this in practice and do a few examples. Remembering that when we have a right triangle, we can use the Pythagorean theorem. And because we know this is going to be examples going off what we just did, our sides right here are going to be the same. Those are going to be our legs. This is a square that was cut in half, so the legs are the same. And so we have x square root of 2 for our legs, and then our hypotenuse. So this one's x, we're going to label. And we're just going to get in the habit of labeling. The more we practice, the better we get. And so if we know that x is 6, because they're on the same side, we know that the leg is 6. If we know that leg is 6, then the other leg is also 6. And then we know that x is 6, so in the place of x, we put a 6, and then we bring down our square root of 2. So for this right triangle, it is a 45 degree, 90, 45, 45, 90. We have 6, 6, and 6 square roots of 2. When we practice this other one on the right, we're going to follow the same thing. This is coming from, it was a square. We're practicing that 45, 45, 90. So we have that our leg, and our hypotenuse follow the formula x x square root of 2. So we can label our sides. That's the first thing that we should do. So when we label our sides, we have a leg is x, and the legs are the same, so another x. And then we have x square root of 2. In this case, we are given 10 square roots of 2. 10 square roots of 2 is going to tell us that the 10 is in the x spot, because these match up exactly. So that means that our leg is 10, x is 10, and the other x would also be 10.